Hey everyone, today I'm showcasing something really exciting, the power of RAG using LangFlow. Now, before we jump into the demo, let's quickly talk about what RAG actually is and why it matters. Normally, when you ask a large language model a question, it only relies on the data it was trained on. And that training data may be outdated, incomplete, or just not specific enough for your needs. That's where RAG comes into play. RAG, which stands for Retrieval-Augmented Generation, solves this by combining two steps. The first step being retrieval. In this step, the system searches an external source, whether it be a knowledge base, database, or even a document store, to find the most relevant information. Vector stores are most commonly used since they offer fast retrieval by calculating the similarities between the user's query and the documents available in the vector store. The second step is generation. In this step, the language model uses the retrieved information to generate a response that's grounded, up-to-date, and more accurate. In simpler terms, RAG lets AI look things up before answering you. And inside LangFlow, we can design and experiment with different RAG architectures using a visual no-code interface. For example, in this demo, I'll be showing you some architectures like AgenticRAG and GraphRAG. Let's start with the most straightforward setup, a basic RAG implementation without using embeddings or any sort of a vector store. Here I'm directly feeding my entire Obsidian vault into the retrieval system without embedding any documents. It's quick and easy to build, but it has its own limitations. For example, since we are passing the entire context, which is my entire Obsidian vault, in a single prompt, it will cost more since there will be more tokens to process. As you can see, this is the prompt and it contains my entire Obsidian vault. Now let's take a look at the chat messages. Here, I've asked it to remind me of my work on a specific topic, and surprisingly enough, it gave me the correct information according to all my Obsidian documents. The flow itself is self-explanatory. In the first node, I'm just loading all my Obsidian documents. As you can see, the loaded files over here, and that's being passed on to a parser, which takes all the content from those individual files and puts it in a format as such, and then those parsed texts are being passed to a prompt template which generates a prompt like this, and that's eventually being chained into a language model of your choice. Over here I'm using Gemini, and that language model generates a response for your query, but using that extra context that it has from the documents you've given it before. Next, let's add embeddings. This setup converts documents into vector representations and stores them in a vector database. When I query the system, it doesn't just look for keywords, it retrieves based on semantic similarity. This makes the RAG system much more powerful because even if I ask a question in different words, it can still find the right information. Now let me explain the flows. If you look a bit closer, there are two separate flows. This bottom one is used to populate a vector database. This node is the same as the previous example, it's just loading all my Obsidian documents, splitting those documents into chunks, and inputting those chunks into a vector database using the Google Generative AI embeddings. This flow is to be used once in the beginning before you actually ask questions. The top flow over here is used when you actually want to ask any question. It's the same as the bottom flow. You're using a vector database or vector store, and you're embedding your query this time. And this would eventually return all those documents which are similar to your query, and we would do the same thing. You would parse those texts, put it into a prompt template, and chain it with a language model, which would eventually generate your response. Now we're stepping it up with GraphRAG. Instead of just storing documents as flat text, GraphRAG builds a knowledge graph connecting entities and relationships. When I ask a question, it doesn't just return isolated snippets. It can follow connections, reason across nodes, and give me a more structured, knowledge-aware answer. This is especially useful for complex domains like research papers or legal documents, where relationships matter as much as the text itself. Now, before I explain the flow, we'll need a knowledge base of our own. So I've populated this vector store, or to be more specific, a graph vector store on AstroDB, where it stores details about animals, like for example a hornet here. It has metadata of insect, number of legs, and its diet. Similarly, we can look at a lark, for example. Keywords are songbird, melodious, ground nesting, etc. And I have around 100 animals in this knowledge base, and we'll be using this to demonstrate our examples. If you want to know how I populated this graph vector store, I'll leave a link to my GitHub repo in the description, and in that repo there's a Python script that populates this AstroDB graph vector store. Now let me explain the flow. As you can see, I'm using the AstroDB vector store in conjunction with the Google generative AI embeddings. And the beauty of LangFlow is that there's a built-in GraphRAG component. All I have to do is just connect the nodes. It's just plug and play. Now this GraphRAG component is just a retriever. So what I've gone and done is asked a question: what animals can I find near the capybara? And if you go ahead and take a closer look, we can see that the GraphRAG actually gave us all the animals that share the habitat of the capybara. So newts live in wetlands, frogs live in wetlands, cranes live in wetlands, dragonflies live in wetlands. And this data is being sent to a parser. It's being stringified, then sent to a prompt template, and eventually sent to a language model. In this case it's Gemini, which is then giving me the answer to my question, as you can see here. So this is the power of GraphRAG. Next up is AgenticRAG. Here I'm combining retrieval with agents, giving the system the ability to reason, plan, and decide how to use the retrieved information. Instead of just stuffing context into the LLM, the agent can say, first I'll retrieve X, then I'll process Y, and then I'll synthesize a response. This setup makes the RAG pipeline more interactive and dynamic, perfect for multi-step reasoning tasks or workflows that require chaining multiple tools. The cool thing about AgenticRAG and its tool usage is that LangFlow has a lot of built-in tools that you could use from the get-go. And if there's a tool that doesn't exist, you could create or use an MCP server and connect it. So I've gone ahead and used the Tably Search API and two different MCP servers to showcase how AgenticRAG works. So if I go ahead to my messages, I've gone ahead and asked it, search for a note called testmd in my Obsidian vault, read the note and use the deep wiki to explain in detail the purpose of the repositories in the note. also search for any good resource on the web. So if I expand this, it'll show all the things that the agent has done. So first it searched using the Obsidian MCP in my Obsidian vault for a node called test.md, and it then read the note and it found this link inside it. This was the only content inside that note. Then it used the deepwiki's read wiki structure function and eventually retrieved all this information. After that, it used the Tably search tool to search for even more information, and in the end it gave me an enriched answer using all that context. The purpose of this demonstration was to show that tools can be used in conjunction with other tools, and the agent can decide what tools to use and what tools not to use. And the cool thing about these RAG architectures is that they're not independent of each other. They can work together. For example, you could have a RAG architecture in which a part of it is a GraphRAG and another part of it is an AgenticRAG architecture, which would kind of be a hybrid RAG, or you could say a fusion RAG. And the architectures that I've demonstrated can all work together in kind of a fusion RAG sense. If you're interested in using any of the flows demonstrated in this video, you can go ahead and check the description below for a GitHub repo, and the JSON files for each of these flows will be included in that repo. That's it for this video. Thanks for watching, and I'll see you in the next one.